Alright, I want to talk about our revolutionary new product. It's called the Maglock. Let me just quickly go over what the Maglock is. It is a magnet that is specifically designed for suspension in prosthetics. That's it. That's all there is to it. It has that is the unlock, okay? And then it has the lock. Now, lock is 90 pounds plus adhesion or strength of the magnet that's pulling it onto here. So you have to put in the unlock to get it to pop off. There we go. And that's in essence what the Maglock does. So the issues with the pin is multiple. One, not being able to find it, the caregiver not being able to put it on, dexterity, blindness, trying to find that hole. How do they do it? How do they put it on? So that was the concept behind this product, is to try to simplify this whole action. Try to take one of the variables out, and that's the pin. So what we've done is we've done the Maglock like I showed you, and we have a smooth bottom that has a very large surface area. Now what that surface area gives us is, I'm going to put this in the lock mode, it gives us the ability to be way off center, way away from where the hole would be, and still have 90 pounds of adhesion. Now through our testing process, what we found in the clear test sockets is a lot of patients might go in this position, but as they walk, they slowly slide the lock over, or not the lock, but the liner slides into center where that liner was designed. So it's doing exactly what we want it to do. It'll go in an off angle, give them the suspension they want, and as they walk, it brings it into the design of the socket. So put it on unlock, pop it off. So primary reason why people can't find the pin is because when patients put on a below knee amputation socket, they come in at an angle. So they hit in an angle. Let me put this on the lock mode, okay? I'm going to put my hand in here to simulate, whoops, sorry. So I'm going to put my hand in here to simulate a leg, back to the lock. And a lot of times they'll come in at an angle and they'll hear one click. That's not enough. When they stand up, they hear a second click. And that means it's now flush with the magnet. That now has full suspension. Now we're good. So a lot of those patients that are having issues with finding the pin, they wait for the second click because that's what they're doing. They're going in an angle, they have a second click. Be aware of that when you're fitting your patient. Don't think as soon as you hit a metal you necessarily have it perfect. Be cautious at first until you understand the system. Now, back to the purpose of this video, talking about how do I fabricate this? What is the best? Well, there's a difference between AK and BK only in the sense of it's a big socket, small socket. Same lock, same adhesion, same fabricating process. When you are casting, the easiest, now I'm going to go with the easiest and then we'll go from there, is to use this little silicone ring, put it on here, on the mag liner, then put the dummy, put it correctly, Dave, and then, by the way, just for fun, the dummy does have a little tiny magnet, so it holds it in position. And if you cast in this position, your spacing and your alignment to the liner is perfect. It's not going to have any issues. If you cast over the liner and come back later and try to get it, you're going to be fudging it. It's not going to be as accurate. Accuracy for the Maglock is important. You can't be a ½ an inch out of the socket and have this work. You can, however, I'm going to kind of shoot forward real quick. I'm going to put this one on the unlock position. It was in the unlock position. I'm going to put this liner in here, and if you'll watch, I'm going to put it just rested in here. Now, listen, I'm turning it on. Did you hear it click? Hopefully you could see it pull down that last thing. That 90 pounds of magnetism can help pull them into the socket. But don't count on that, okay? Make sure you hear metal before they stand. You hear the metal click, it's safe to stand, okay? So, this cutaway, and this is a cutaway, this is not the way we're fitting the socket, it's purely for demonstration purposes. If we cut it away all the way down to the magnet, we are going to have an extremely weak point right here. and this is where that socket's going to break. On the other side, however, we have a hole because this is a slide mechanism. Now the slide mechanism is all about how this was figured out by a person in Malaysia. Her name's Arzu. She figured this out, and basically she's sliding magnetism out of sync. And when we get it out of sync, it lets go. When it's in sync, it holds on. So there's a little bit of remaining tension even when it's out of sync, but not enough to keep somebody left in the socket. But fabrication-wise, I wanted to point this out. We're very close to the screw right here. This is critical, this area. This has to be supported by a very tough, strong material. Now this particular lamination is a combination of carbon fiber and NSP. NSP is 10 times stronger than carbon. It is not brittle. It is extremely hard to break it. So the NSP is going to give me my strength here, not the carbon. The carbon is going to give me stiffness. The NSP is allowing strength in here. And I highly recommend that any of these locks with the slide, with this hole that we have to put in near the screws, that we use NSP in this area to make sure it is adequate strength. Nylon stockinette, fiberglass, carbon fiber, all are not strong enough within themselves. If you're going to use carbon fiber, add the carbon fiber strips to make sure you add some extra strength within that. If you are using a carbon or a fiberglass, both of them are coated with an epoxy coating. It's called sizing, but that's epoxy. The reason why is nothing sticks to glass and nothing sticks to carbon. So they have to completely encapsulate it in order to give it something to hold on to. But in essence, that weakens the bond between resin and fiber. NSP does not have any sizing, and the bond between the resin and the fiber is much stronger, and that's why I'm totally recommending you use that when you're using a Maglock. So, another point with anybody doing any kind of puck lock, even if you have a small hole, is if you use a 4-prong or 4-screw and you have a corner, that corner is your weak point. If you have a round disc, it distributes it over a greater surface area. If you're using this, make sure you understand that this needs to have adequate material to support it. So make sure you put in enough NSP or add extra carbon strips whenever you have a 4-hole adapter on a round surface. Okay. There it is. Dummy. I want to talk about the dummy real quick. So the dummy has a hole for the slide and another side piece that is made to hold in here. What I do is I put a little bit of putty in the back and I push this in until it finds home and it sticks. Hopefully you can see that this has a taper to it. So when this is all done, the lamination is all done, and I push it off as best I can on the top, and I grind down to this surface. If I add the screw to it, to that hole, also fill that hole with putty when you're doing it, and I screw the screw in, it will pop this off. Now we have a round surface, and this will come out of the lamination without any extra effort. Okay? Any that we have a 4-hole laminating adapter so that you can put a plate on top if that be the case. The side piece is very important. Make sure you take care in how you set that up. Take care in how you lay your fibers around it. So if you can stretch fiber over it, around it, excuse me, instead of over it, it's going to be stronger. Every time you cut a fiber, you're weakening it. So try to stretch around those corners to make it stronger. Alright, now remember I said the easiest way is to use the Magliner. It's lower profile, it's easier to do, etc. But being a prosthetist, I understand that we all have our favorites. And it might necessarily be our liner. So what we've done is we've made an adapter for any pin liner. To take the lamination to do the casting, we have another silicone ring that can go on here. And what's that doing is it's changing the undercut, so there's no undercut. We can put on this adapter, And this screws into any liner, remember, so you can hook that up with anybody. And then you can put the dummy on top and do your lamination. Okay? Now, just a little word of caution. There are so many designs of the nipple on the pin liners. We couldn't make an adapter for everyone. So these will get you close. You might have to do a little fill. The most important part is that you don't have an undercut. So in other words, if I take this off and I put this on, that'll over accentuate it. And if I did a cast, I have an undercut. This dummy is now stuck. And I'm really going to be, it's going to be an impossible time trying to get it correctly. So put in the silicone rings or fill this in with putty or do whatever you can so there's no undercut and just a smooth transition. So again, the easiest way, go for the mag liner. Check that one out. If it's a liner issue and you're just not comfortable with it, go with your own liner so you can prove that about the lock, prove it to yourself about the lock, and then try the mag liner.